Hey there, U8s. This is Mr. Herman here, and this is exercise 3H, finding and expressing as a percentage. Learning goals for this one is to get a better understanding of the properties of percentages, and the success criteria is to be able to express one quantity as a percentage of another quantity, and to be able to find a certain percentage of a quantity. So showing values in percentages, it just makes it easy for us to make comparisons. So for example, Huon's report card could be written as marks out of each total or in percentages. So there's two different sections here. Huon's got a French test, which is 14 out of 20, and a German test, which is 54 out of 75. Now it's hard to do a comparison as to which one is better or worse because they don't have the same allocated marks for each test. So which one did he do better at? Which one did he do worse at? It's hard to determine. So this is where we can convert them to a percentage. So how many marks did he get per 100? For his French test, he got 70%, and for his German test, he got 72%. So obviously his German test is better because it's more in percentage. So it's clear that the German score has a higher result. And comparisons like this is easy when proportions or fractions are written as percentages. Expressing one number as a percentage of another number is a technique covered within this section. This is what we're going to delve into. Another common application that we can do for percentages is to find a certain percentage of a given quantity. So throughout your life, and I know in my life as well, you will come across many examples in which you need to calculate percentages of a certain quantity. Examples include retail discounts, some interest rates when it comes to banking, personal improvements to compare one to another. Maybe you're trying to beat a record of some sort and you want to know what the percentage of that record could be. Salary increases or decreases if you're unlucky, commission rates, the list goes on. And what we mean by finding a percentage of a quantity is finding 20% of 200. What's 10% of 6? What's 150% of 90? These are percentages of quantities. So how we tackle this? There are two different methods that we look into. When we want to express one quantity as a percentage of another quantity, that is just saying that maybe we want to show, just like a test of some sort, 33 out of 52. And we want to know, well, what is this as a percentage? How much did this person get out of 52 as a percentage if 33 was the score? What we do is we write the fraction with the part amount as the numerator, which is in this case 33, and the whole amount, what it's out of, as a denominator, and convert the fraction to a percentage just by simply multiplying it by 100. So for example, this one over here, a test score of 14 out of 20, and there are two different ways that we can approach this. The first way is write it as 14 out of 20 and multiply by 100. Now there's this different cancellation method that's going on here. If this looks too confusing, don't worry about it because I have my own process that makes a bit more sense to this. Either way, you'll end up getting 70, or in other words, a 14 out of 20 is the same as 70%. And we're going to look into an example of how to tackle this. Alternatively, if you know 14 out of 20 should be some number out of 100, how to get that some number is to get 20 and multiply it by 5. And whatever you do to this bottom, you also apply it to the top. So 14 times 5 is 70. So 70 out of 100 is also the same as 70%. If this was 10, and maybe it was 5 out of 10, as an example, to get it to equal something out of 100, you would just have to multiply this by 10. Again, whatever you do to the top, you do to the bottom rather, you do to the top. So in this case, this is 50 out of 100. That makes sense. 5 out of 10 is the same as 50 out of 100. This will end up being 50%. And to also find a certain percentage of a quantity, the first step you're going to do is express the required percentage as a fraction first, change the of to a multiplication sign, express the number as a fraction, and then follow the rules for multiplication of fractions, which we've seen in the previous exercises. So in this example here, we're going to find 20% of 80. So 20% of 80, 20% is written as 20 over 100, and 80 is just obviously written as 80 over 1. Now there are different processes to how to calculate this, and I'm going to show you my process, but after everything, you should get 16 So 20% of 80 is 16. So alternatively, 20% of 80, you can just write it as 1/5, because 20% is the same as 1/5 or something, and change of to a times. 1/5 of 80 is the same as splitting 80 into 5, and this is also 16. What this is saying is, if we had 80 over here and we know that this is 1/5, if we had to split this up into fifths, we know that there's 16, 16, 16, 16, and 16. All 16s, when added up, all 5 of them will give you 80. We're just looking for one of them. If this was 40%, it would be 2 lots of 20%, which is 32. If this was 60%, 80%, and obviously 100%. 100% of 80, well, it's obviously 80 because you're asking for the whole amount. So this is a cool little visual to see what's going on. Remember, either way will suffice. I will just show you my method and how to tackle these type of questions in examples. So let's look at this first one over here. Express each of the following as a percentage. The first one is 34 out of 40. So 34 out of 40. In order to get this as a percentage, we're just going to times this by 100 and get a certain percent. But you'll realize that 34 out of 40 can actually be simplified. So the highest common factor between 34 and 40, because we know they're both even numbers, let's make 2 our highest common factor. It might not be the highest common factor, but it is a common factor between 34 and 40. So how many 2's go into 34? This would be 17. And how many 2's go into 40? 20. So we'll rather do 17 over 20 as opposed to 34 out of 40. It's still the same fraction equivalence. We're just simplifying it, so the math behind it will be easier. We're going to put this 100 over 1, and we're just going to apply our fraction rules for multiplication. 17 times 100 is 1700, and obviously 20 divided by 20 times 1 rather is 20. Neat little trick. Every time you see a 0, we can cross it out. So effectively, this is just 170 over 2. How many 2's go into 170? This is equal to 80. So 2 goes into 16, and we've got 1 remainder, so 5. So 170 split up into 2 is 85, and this is a percentage. So the amount is 85%. This is saying 34 out of 40. If you were to get a test, this is equivalent of 85%. Now this step over here, I knew 170 divided by 2 is 85, but if you're struggling with the division, you can always do your division process in order to get to that solution. 13 out of 30. Now 13 out of 30, obviously, for me it's obvious that it can't be simplified. It might look like a 3 can go into both numbers because there are 3's involved. The 3 actually cannot go into 13. It can go into 12, but it can't go into 13. And because 13 is a prime number, we can't really simplify it anymore. So we just put it straight into this. 13 times 100, 1300, and 30 times 1 is 30. Cross out your zeros. So we're trying to figure out how many 3's can go into 130. So 3 into 130. How many 3's go into 13? This was 12. So 3 into 13 is 4, because it goes up to 12. That's what I was meant to say. With one remainder. 3 into 10 is 3 with 1 remainder. We end up getting a bit of a pattern here, recursion. 3, 3, and this keeps going. So this will be 43.3 with a little dot on top to indicate it is a recurring decimal percent. We're now going to convert units, and these units, these are unique ones. And I'll show you why. The first one, we're going to express 60 cents as a percentage of $5. So for instance, say there was a goal of some sort that you saw a certain thing in the shop and it cost $5. And you said, oh, I've got 60 cents. What is that as a percentage? How much percentage-wise have I saved up so far? And it's going to be a relatively low amount because it's 60 cents. So we're going to first express this as a quantity of one of another, so 60. Now, a lot of students fall into the trap where they put 60 over 5 because it's 60 cents of $5. But $5 is a different unit to 60 cents. We have to change this into cents. And if there's 100 cents in $1, there'll be 500 cents, and $5. So make sure your units are correct and the same. And we just multiply this by 100 over 1. 60 times 100, 6,000. And 500 times 1 is 500. For every 0 we see, cross out, cross out, cross out. So this is asking how many 5s go into 60. If you could with your multiplication, this is 12, because 5 times 12 is 60. So 12% has been saved so far, which isn't a big percentage, and that makes sense. If we're in the cents, no pun intended, if we're in the cents domain, and we're trying to get $5, then yeah, it's going to be relatively low. If it was just $1, well, that will be 60%. That will be quite high. Because it's $5, it will be a lower percentage. B, we're looking at 2 kilometers as a percentage of 800 meters. Now, what's going on here? We've got 200 kilometers, which is greater than 100 meters. If you were to read this in the form of a context, let's just say that every day for training you ran 800 meters. If you were to run exactly 800 meters, you would have covered 100% of what you intended to run, because 100% of 800 is effectively 800. If you did less, then obviously the percentage that you would have obtained would be less than 100. In this case, because how much we've run in comparison to what we expected is more than 800, I'm expecting a solution that is greater than 100%. And I know this this topic or this unit seems a bit arbitrary, but a bit random. How do we get a percentage over 100% if 100% is at its fullest? Well, this is if we are comparing it to something when we go higher than what we anticipated. This is where over 100% actually works. So we've got to express one quantity as another. So 2 kilometers is the same as 2,000 meters over 800 meters. Remember, you're going to make sure that your contexts are all the same. And we're going to times this by 100 over 1. In other words, this is 2000 with another 2 zeros. So 2000 times 100, add another zeros, over 800. Every 0 we see here, we cancel with the top. And this is asking how many 8s go into 2000. 8 into 20, 8, 16, which is 2. The 4 remainder. 8 into 40 is 5. And 8 into 0 is 0. No remainder. So effectively, if we're putting it in a run context, we've run 250 times the allocated amount that we intended. Or in other words, exactly 2.5 times at what we anticipated. So this is where we can get solutions that are greater than 100%. And it does make sense if we're comparing a higher amount something that's lower. The last example here is we're trying to find a percentage of a quantity. So the two examples, we're finding 25% of 128 and 155% of 60. So 25%, there are different ways that we can approach this one. One way is 25% we can write as 25 over 100. And we're going to multiply this by 128 over 1. Now I look at this and I think, there must be a simpler way, and we'll still approach this way, but to work out 25 times 128, that's going to take a while. But I also know that 25 over 100 is the same as 1/4, is it not? Because when we simplify this, the highest common factor between 25 and 100 is effectively 25. It goes into 25 once and it goes into 100 4 times. So instead of complicating it, let's simplify what we can first and then work this out. So this is 128 over 4. How many 4s go into 128? How many 4s go into 12 is 3. No remainder. How many 4s go into 8 is 2. No remainder. So 25% of 128, or 1/4 of 128, is 32. Now remember, we're not dealing with a percentage as our answer, we're dealing with a percentage within a question. So I don't want to see 32%, because 25% of 128 isn't 32%, it's exactly 32 of whatever the unit is. If this was dollars, then 25% of $128 is $32. If it's grams, the answer will be grams. So just be wary of the context. Last one is 155% of 60. Now there are two ways of tackling this. There's always multiple ways. 155 over 100. Now this is an improper fraction, but remember we're getting a quantity that's more because it's over 100, so I'm expecting an answer that is greater than 60. This is going to be multiplied by 60 over 1. Now, can we simplify this a bit further down the track? We know that there is a high common factor of 5. So let's see how many times 5 goes into 15. This is 31. And 5 into 100 is 20. Now you can use your long division process, but I know there won't be any remainders. There can't be because we're trying to simplify. This is going to be 60 over 1. Now we can deal with maths that's quite simpler. There are different ways that we can simplify this, but I don't want to get this too confusing. Let's just continue on with the process. 31 times 60. Because it ends with a 6, I know it's just going to end with a 0 as an answer. 6 times 1, 6, and 6 times 3 is 18. So this is 1860 over 20. You can identify that there are zeros here that we can simplify. So how many 2's go into 186? This will be 93. Again, you can do your long division. 2 into 18 is 9, no remainder. 2 into 6 is 3, no remainder. So our final solution is 93. And that makes sense in the scope of making sure that our solution has to be greater than 60. Because we're asking for a percentage that's more than 100, so we're getting a little bit more than 60, or halfway more than 60, so it is 93. Now the questions that you need to do will be from page 159. I'm just going to quickly grab there we go. The questions you need to do is 1 to 4, all left hand side. I want you to do the first 3 of 5, the first 3 of 6, so 5 ABC and 6 ABC. Question 7 to 9, all left hand side. Now I know I've just allocated one period for you to work on this. Assuming that lockdown is finished, we will continue this and we'll do a bit of a revision catch-up session when we do get back, just to make sure that everybody's all grounded regarding what work is expected, because I know some of you guys are here for remote learning and some of you have been away. So it makes it a bit tricky for me to know or delve into it. Remember, all of these questions can be found in resources within Compass, so have a squiz, or you can use your textbook if you've taken that home. All right, hopefully this is the last video I have to create remotely, assuming we come back to school the next week. Till then, I'll see you guys soon. Ta-da.